ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ನಾನು ಮನುಭೂಷಣ್ ಡಿಸೋಜ. ನಾವು ಲೈನಕ್ಸ್ ಎನ್ವೈರನ್ಮೆಂಟ್ ನ ಬಗ್ಗೆ ಕಲಿಯುತ್ತಿದ್ದೇವೆ. ಇಂದು ನಾವು ಸೆಷನ್ 17 ಇದನ್ನು ನೋಡಲಿದ್ದೇವೆ. In this session we are going to talk about link and unlink system calls in Unix operating system. The learning objective for today's class is to understand the process of linking and unlinking operations of file system. In order to appreciate the content of this particular chapter, you need to have the basic knowledge of a Unix file system. So let's look at what is a link. We are all familiar with the shortcuts. So in Windows we create shortcut. So shortcut is nothing but a link to an existing file. In the similar way, link system call links a file to a new name in the file system directory. So whenever you call a link creates a new directory entry for the existing node. Now we are familiar with linking in Unix file system. Let's look at how we can create a link. I'm going to create, I have my Unix system running here. I'm going to create a new empty file here and I'm going to call that as my file. Let me call everything in small case so that it is much easier for me to do that thing. So I have created a file called as my file. Let me open the terminal and I'm going to switch to the desktop. If you look at here, if I do the ls on this desktop, you will notice that, let me zoom in for you. You will notice that there is a file called as my file. So that's the file that I am referring to. Now we know that in Unix we can create a link using ln. So if I create ln minus s, s refers to I am creating this sublink for my file and I am going to call this as, let me call it as my file, and I am going to create a shortcut called as my shortcut. When I do that thing, a shortcut is created. Let me show you that thing so that you can easily look at them. So we have both of them, shortcut and my file. Now let's see some of the things that we have to understand about it. I'm going to use ls minus li on these two files, that is my file and my shortcut. Few things that you must notice over here is, first very important thing, this is the inode that I am referring to. So the inode of my file is 81713 and you notice that the inode for my shortcut is different. That means my shortcut is a separate file by itself. We know that in Unix every file is associated with a inode, and if the inode is changing, that means it's a different file altogether. So both of them are different. What is the speciality of this one? You notice that my shortcut is actually pointing to my file. So that's simple as that. Okay. Other thing that you will notice over here is both my file and my shortcut have only one link. Even though the shortcut is referring to my file, the link count is not changed. Let me rename my file to something else. So I'm going to go here and I'm going to move this file called as my file as your file. So the file name has changed. Let me bring it closer so that you can see. So my file has changed to your file. Let me now run the same command, that is the ls minus li for both of them. So because I don't have my file anymore with me, So I'm going to use your file. So if I run this, you notice that your file is just the file name that has changed, and you notice here the inode number of your file and the inode number of the original file, that was my file, remains same. So it is 783. However, you notice one strange thing over here. The whole thing will come in red color, indicating that this shortcut is no longer available. Now if I rename this, suppose if I move your file to my file, naturally it's going to change to my file. And if I now use the ELS on the my file, and you notice that all are working fine. What I've just created is a soft link. I can create a hard link by using ln with the original file name, and I'm going to call it as other file. So you notice that a other file is created, and you notice that it is not a shortcut, it is just a ordinary file that is getting created. If you look at the properties now about let me click here. So ln minus li, I have three files now: my file, shortcut, and the other file. Let me show you all of them. You notice a strange thing. First thing you will notice that for other file and my file, the inode number is same. What is the meaning of saying inode is same? Let us recall again that for in a Unix system or in a Linux system, every file is associated with a inode number. So if the inode number is same, that means both of them are same file. So this is the same file, and this one is also the same file. Okay. Next thing that you have to understand is that here the link count is reduced by 1. Okay. Let us go and let me edit it. I will manually edit this one using the gedit. So I'm going to just add a few names here. So I'm going to say Ramesh, Ravi, Lakshmi. Let me put it in next line. And let's say Radha. Some names I have put it here. So I have saved them. Let me close it. Now I'm going to list the content. So I have made the changes to my file. So I'm going to use the cat command here. So cat, or I can just open this one now, other file. I made changes to this one. Let's open the other file, and surprisingly you notice that even though I have not made any changes to the other file also shows the same content. That means it is pointing to the same file. So both of them are same. Now what if I remove the my file? So this time I'm going just to clear it, just to make you understand. Okay, clear the content. I'm going to remove the my file. If I remove my file, so my file is gone. You can notice over here my file is gone. Let me go here and let me use the ls minus l. So remember that my file is not there, so I'm listing now. So if I list one file is not there, so my file is not there because I removed it. Now you notice that the other shortcut that I am using is showing me in red color, saying that the shortcut is no longer valid. However, you notice one other thing. The inode number is not changed. Inode number still exists, but the count has been reduced by 1. That means there were 2 links were there. Now the links has been reduced by 1. Okay. What if I want to remove a shortcut? Suppose if I say remove my shortcut, it will be removed. Okay, I think my spelling should be proper. So my shortcut, okay. Let me ls on this, okay, and let me say remove my shortcut. Okay, it's been removed there, so I have removed it. Also, how do I remove the other file, like the ordinary file? How I would have removed it? I can remove the ordinary other file called as other file, so that will also be removed. So this is how we create the shortcut in Unix. Now let's come back. With that knowledge, we can come back to our PowerPoint here. So link is used to create a shortcut. Okay, so in technically we say that a link is a system call that links a file to a new name. Okay, it just adds a new directory entry in the for the existing inode. The command for creating the link, that is the system call, is link followed by the source file name and the target file name. Source file name is an existing file name, target file name is the new file that you want to create. Okay. One very important thing, when you create a short or a soft link, okay, the Unix kernel does not check for the existence of the file. You have already seen I created my shortcut and I deleted the original file. So then there was an error. Okay, so the kernel actually does not go and verify whether that file really exists or not. It assumes that the file exists and this creates the link. So it will not treat a link as something as a separate new thing. It's just a file as such. To give you a simple example, I've shown you the example with the ln command. The link command remains the same. You create a source file, you create the target file, and after the link creation, the test file will be pointing to the real file. So as simple as that. Okay. Now when it comes to creating the link to the directories, we are all familiar that we cannot create hard links for directory. Only super user is allowed to create the link for directory. This is to minimize or simplify the coding. The other problem that happens if a user creates the hard link for the directory. So if the Unix allows every user to create a hard link for the directory, then it will so happen that the program which is parsing, program which generates the tree structure, may end up in infinite loop, because one directory may be linked to other directory and that directory may in turn link to some other directory, and you may end up in a circular references. In order to avoid all these problems, only super user who is assumed to be a bit careful is allowed to create the links for the directory. So suppose if I go to my Unix file system and if I slightly zoom in for you, and if I try to create a directory for you, let me clear it so that the clear command. So I'm going to create a directory mkdir my I'm going to say my folder. So I just created my folder. Let me show you my folder. So it is coming there now. So if I use ls minus l, you notice that it's the directory. Okay, this is the directory and this is also a directory. This is my folder. What if I want to create a soft link? So to create a soft link, you just say ln minus s followed by my folder and my short folder, let's say. Okay, this is a soft link, remember, so everything goes fine. It's a soft link. Remember, soft link is a separate file that is just pointing to the existing file, and if I delete this, this shortcut will be invalid. If I want to create a hard link, then let me go here, ln followed by my folder, and I'm going to create a other folder. So this is a link again, but I am creating a hard link. So if I try to create it, you will notice that that's not allowed. Okay, I cannot create a hard link for the folders. Only administrators are allowed to do so. Let's go to the PowerPoint now. Okay. Now, when we create the link using ln command, we don't have something called as unlink. We have to just delete the link. Whereas in the system call, you can always use unlink command to unlink a file. That means you are removing the shortcut. Okay, unlink followed by the name of the file. That is the full path name of the file. As usual, when you unlink a file, the file will not be no longer be available to the others. So if you just look at this particular program, in this program I unlink this file. That means this my file has been unlinked now. Now if I try to open it, then I will end up in an error message because this file has already been unlinked. Okay, so unless you create a link again, maybe use the same file name for other file or for the existing file and create a link, you will get a error message. So if you unlink it, the link is lost, then onwards the link will be no longer available. It is as good as you are deleting a file. Okay, as usual, when you unlink a file, its count, that is how many link reference will be reduced if there are more than one link that is available for the file. For example, if you have the original file here and then you have the links for this particular file, so number of links, let's assume that these are all links. I am just showing you visually. So there the count will be, in this case count will be 3 links are there. So altogether 4 are referring to this. Suppose if you remove one of them, then the link will be reduced to 3. Suppose if you remove this link, that is unlink it, then the link will be reduced to 2. Suppose if you remove this one, then the link will be reduced to, number of link count will be reduced to 1. Now when the link is 1 and if you use the unlink, if you reduce this, it's going to become 0. When it is 0, the inode that is associated with the file will also be removed and the data blocks will be freed altogether. So it is as good as you are deleting the last reference. When you delete the last reference, naturally the file has to be wiped out from the disk. So it is simple as that. Okay, otherwise if there are several links are there, so if the link count is more than 1, then the link count will be only reduced, the original file will not be touched. So the file will be reduced when its last reference or file is deleted, when its last reference is deleted. When the last reference is deleted, the file is physically deleted or its data block is physically freed. Until then, it's only the changes in the inode that are being made. So in the inode, we just reduce the number of references by 1. So if you have 10 links, if you delete one of the link, then the total count of links becomes 9. If you reduce one more, the total link reference count will become 8. And if you reduce one, it becomes 7, and so on. Until the link reference is 1, that is link count is 1, the file will not be removed. So if the link reference is 1, that means only one the directory is referring to that particular inode, and if you remove that entry also, that means this file is no longer required, nobody is referencing it, so then its data block will be freed. Thank you for your interest. We will meet again in the next class. Thank you.